the issue of how salt melts ice. There is confusion about it. If you read in the literature, it tells you the salt will lower the melting point or the melting temperature of the ice. Here, if you don't pay attention to the language, the melting point is different from the temperature of the medium. For example, how do you melt this ice with salt like this that have the same temperature? It is not a matter of thermodynamics. The three laws of thermodynamics, the temperature gradient or the difference in temperature determines how the heat is transferred. So the salt have the same temperature like the ice. So how does the ice melt? By adding the salt to it. Look at this last piece of salt. It did not melt because it is mixed with dirt. But the rest of the salt that was sprayed melts with the snow, with the ice. So how does the melting happen if it is not difference in temperature? The melting happens by change of the amount of heat required to melt the snow. They call it the latent heat of melting, or the latent heat of freezing, or the latent heat of evaporation. Look at the composition of the salt. The salt is made from, this kind of salt is made from two kinds of salt. The sodium chloride, which is the sea salt, and the magnesium chloride, another salt found in the ocean, magnesium chloride. How does the salt melt the ice or the snow when it has the same temperature? It is simply by providing a contact surface. The way they make the rock salt in the factory, they get the salt from the ocean or from the lake, they compress it at very high pressure, they create what you call it rock salt. Rock salt is the same salt you use it at home, but it's compressed in crystals. The crystals can reach up to 1 centimeter in dimension. So you create a compacted salt. When you put it when you throw it on the ground like rocks, it adds surface, contact surface to the particles of the ice. So it disturbs the bonding between the molecules at that surface. The contact surface will alter the melting point. Remember, it does not alter the temperature of the snow. The snow does not melt because it got heated. It does not. The salt does not warm the ice. The salt lowers the point at which the ice can melt. So for example, if the ice melts at 32 degrees at the atmospheric pressure at sea level, when you add salt to it, it can melt at 25 degrees when it's supposed to be freezing. So you did not change the temperature of the ice by adding salt. You changed the point at which the ice can melt, which is the amount of heat required to be removed from the water to make it freeze. It's called the latent heat of freezing. That amount depends on the purity of the salt, the structure of the crystal, and how easy for the atoms to grasp each other and bond and create the snow crystal or the ice crystals. That settles the problem about how salt is used in the icing when it has the same temperature, despite the fact that thermodynamics prohibits the transfer of heat between two mediums at the same temperature. As a matter of fact, thermodynamics does not apply to microphysics. In thermodynamics, you use it only in macrophysics. How do you define the temperature of the atom, of the electrons, of the protons? You cannot. You only define the temperature of a population of atoms, material, not the atoms, not as singular atoms. So the salt provides that kind of service that disturbs or changes the purity of the bonding network at the contact between the salt rock particle and the snow. So the melting happens at the surface of contact. So, and it keeps spreading through the snow, so you can see the snow is melting next to the salt, despite the fact that both of them have the same